Hello members, welcome to Molten Heights Education Services. Don't forget to subscribe, hit the button, don't forget to comment and like. Today we are going to talk about integration. Integration is a topic in mathematics. To give a brief background of integration, integration started way back in the ancient times of mathematicians. Mathematicians were asking themselves the question, how can we find areas, how can we find volumes of spaces or under curves that are indefinite? For example, if you're given a curve like this, if you're given a curve, say it's like this, and it's running from A to B, how would you get this area of a curve? How would you get the area under this curve? In geography, you can estimate this area of a curve, but the method is not very accurate. So mathematicians came up with a method of how to get the area under the curve given the limits or given the points where the curve was running and where it was ending. That mathematician was called Archimedes. He came up with a method of integrating from one point to another to get the area under a curve or to get the volume of under a given shape. I think some of you have come across trapezium rule. Trapezium rule is another format of integration. You could be doing it, but when you're not aware that it's part of part of integration, but it's another format of integrating, but in a formal way. Okay. We begin with the definition of integration. We shall consider a curve. We shall consider a graph of fx the function fx is described in such a shape. Now, say we want to find the area from point we want to find the area from a point A to a point B from our curve. What shall we do? We shall try to interpolate from the curve to the point where A is, and also extrapolate to this point. So we want this area. I've told you earlier on that in geography, they can estimate the area under this curve, but that method is not that accurate. So mathematicians came up with a method. For mathematicians, the integral or the method of integration for this, it would be the integral running from point A to point B of this function. Now for this function, what is changing? The values of x are changing. That means x is a variable. If x is a variable, then we shall have we shall have the x. And this is the area. This is the definition of integration. By this, we shall be able to find the exact area between A and B. Now, this definition is for a definite integral. Definite is something that you're certain about its beginning and its ending. Then indefinite, you don't know the start and the ending. So for indefinite, it would be this is a definite definition. Now let's ask ourselves if we are finding an indefinite integral. So for an indefinite integral, let's call this one L1 for purposes of differentiating both. So for an indefinite integral, let's say we are still considering the same function, but you're not certain where we're beginning from, where we're ending from. So for this one, it will be the integral of f of x dx. But remember, we are not certain where we're beginning from and where we're ending from. So after integrating this, we shall put an arbitrary constant, which is denoted by c. Integration is the opposite of differentiation. For differentiation, we are saying we get that power of the variable, we subtract it by 1, then we multiply it at the base. What am I trying to imply? If we're having x squared and we are differentiating this, we shall say we are reducing the power by what? By 1. So it will become, let's say this is equals to y. So it will become dy dx. We are reducing the power by 1. That is x. 2 minus 1, which is 1. Then we multiply the original power at the base. This is the opposite of integration. For this case, if we are integrating this, we would increase the power by 1. Then instead of multiplying it at the base, we divide it at the base. What am I trying to imply? If I'm having x squared, it would be x increase the power by 1, that will be 3. Then the new power is multiplied, it is divided at the base. So it would be that. So basically, integration is the opposite of this differentiation, and differentiation is the opposite of integration. So the general format of this would be, if you are given a function f of x, which is equals to x power n, and we are integrating this, let's take this to be an indefinite integral. We don't know the limits, the first limit and the last limit. We don't know them. So if you're integrating this, the integral of f of x is x power n dx. We say we are increasing our power by 1. So that will be x n plus 1. Then this new answer we've got, we multiply it, we divide it at the base, which would be x plus 1. Since it is indefinite, we put an arbitrary constant c. So this is the format of integration. So let's get examples of integration. And we are going to begin with polynomials. So let's look at examples of integrating polynomial functions. Firstly, polynomial functions are in the form ax squared plus bx plus c, but this can be any other power. It can be x power 5, x power 6, yeah, where a, b, c are just constants. So when we look at examples, and by the way, a polynomial function can only exist as f of x is equal to c. That's another polynomial function. F of x is equal to bx plus c, only that. Not necessarily that it should be in this format. It can be in this format, or it can be in this format, but missing, say, a term of x, or missing a term of c, a constant. So the examples are, we have integrate 2 dx, then integrate x squared dx, then integrate x squared plus 2 dx, then integrate x power negative 1 dx. Let's first leave this one. Let's put maybe this one for let's first solve the first one. They want us to integrate an integral of 2 with respect to dx. If we are integrating, we should not forget our variable. If we forget our variable, then our integral has no sense. The question would be, what is our integral varying with? Without the dx, this can be dx, dy, or anything that is varying. So without this, a person will not know. A person will not know what is our function varying with. Say 2 can be a function of y, but this 2 is defined by x. This x is x power 0, and this x power 0 is the one that is what? Varying or changing. So if we are integrating this without putting this, then it loses sense. What is it varying with? So whenever we are integrating, we have to attach this variable dx. So if you are integrating the integral of 2, that is part A, if you are integrating 2 dx, when you look at this, this is varying with x. That means there is a silent x here, but that x is x power 0. So this would be this would be 2x. This is power 0. We add a 1, that is 1. So 0 plus 1 is 1. The result, we divide it at the base, which is 1. So that is 2x power 1 divided by 1, which is 2x. Since this is indefinite, attach an arbitrary constant, which is c. I think that one is done. Then our next example is x squared dx. This is our function is x squared. varying with x. Okay, our variable is dx. So our power is initially 2. We increase it by 1, which is 3. Then we divide the new power at the base, which is 3. So this is our integral. Since it is indefinite, we attach an arbitrary constant. Then we have this example. This is example C. If you are integrating x squared plus 2 dx, this whole function has a variable x. In short, we are integrating it with respect to x. For this, we already obtained it here, but for purposes of consistency, this is our initial power was 2. We increase it by 1, which is a 3. We divide at the base, which is x power 3 over 3. Then we have this. This is 2x power 0. 2x power 0. X power 0, we increase it by adding a 1, which is x power 1. Then the new power is divided at the base, which is divided by 1, which is 2x plus the arbitrary constant. Now, I charge you to try for me part D. And the answer you get, don't forget to comment in the comment section. If you find challenges, please, I urge you to put your query in the comment section. Now, this is a take home. If we're told to integrate x power negative 1 dx, how would you solve this? So this is your take home. If you find solutions of this, drop them in the comment section. If you find challenges, it's very okay. Molten Heights Education Services is the place for you. Any problem in mathematics, physics, chemistry, biology, this is the rightful place for you to air out and to solve your problems. Thank you very much. Don't forget to subscribe, comment, and like.